Do you have students who get frustrated with math, or students who find math boring and disconnect? We want to help you answer that famous question, when am I ever going to use this in the real world? The New Manufacturing Alliance is a group of manufacturers working with educational institutions, workforce development boards, chambers of commerce, economic development, and state organizations to promote manufacturing in Northeast Wisconsin. The Get Real Math video started at a K-12 task force meeting in October of 2012. A math teacher asked if there were applications the industry uses that can help show students relevancy for math in the real-world application. Industry partners saw this as an opportunity because there are strong needs for math and problem-solving skills in manufacturing. The project met the needs of both the educators and the industry. This was a total collaborative effort with the support of Green Bay Public School Systems and the area manufacturers. The decision was made jointly to create videos that teachers can show in the classroom. There are videos created for elementary, middle, and high school levels. They're tied to specific Common Core standards, and lesson plans are written by a math teacher. 5 Get Real Math videos were initially created with the format of explaining the problem, discuss what is needed to solve the problem, the impact of mistakes and scrap, and the solution. There are now over 50 videos and lesson plans available, with more being produced each year. Here are 3 sample videos for different student levels. Be sure to click on the links for the full video and lesson plan.
This is made from that. This paper machine produces tissue at a rate of 5,000 feet per minute. In less than an hour, it produces a huge parent roll of paper that weighs over 7.5 tons.
This machine can produce 30 parent rolls each day. The width is 262 inches and contains 240,000 linear feet of paper. How many square feet of paper on each parent roll? To calculate the square footage, we need to multiply the width by the length of paper. First, we need to convert the width from inches into feet. So we need to divide 262 inches by 12 inches, which gives us 21.83 feet. Now we can multiply 21.83 feet by 240,000 feet, which totals 5,240,000 square feet of tissue on each parent roll.
The paper is made into rolls of bath tissue. Each roll is 4 inches wide and contains 187.5 lineal feet of paper. How many tissue rolls could be made from one parent roll of paper?
Ship stability is an area of naval architecture and ship design that deals with how a ship behaves at sea, in still water and in waves, whether intact or damaged. Stability calculations focus, among other factors, on the center of gravity.
The center of gravity is the point at which the whole ship is balanced, and it will remain upright, like one of those punching bags with the sand at the bottom, that when you hit it, it will return upright.
You'll need to sharpen your pencil here and use deductive reasoning and your knowledge of weights and moments to use these critical problems. The primary principle is that the ship's stability relies on the center of gravity and the vessel falling below the center of the ship's buoyancy. This value is called the transverse metacenter and is generally called out as KMT. KMT is measured as the distance from the bottom of the ship to the metacenter. The metacenter is a function of the geometry of the ship. As long as the center of gravity falls below KMT, the ship will be stable.
The following mathematical model is at work, and for simplicity, the value of KMT is provided to you. Center of gravity is calculated by the weighted average of all items on the ship when taken from the common reference point. Typically, on a ship, this reference point is the bottom of the ship, or keel, where ZCM is the center of mass in the Z direction, up and down. MI is the mass of the individual objects on the boat. ZI is the vertical center of mass of the individual objects on the boat. M is the mass of the entire ship, or sum of MI.
Here's a sample problem for you to tackle. Fincantieri Marinette Marine is building a ship for a customer that would like to transport cargo across Lake Michigan. Using the data provided, determine if the ship will be stable as it transports the cargo. Here are the 4 questions. 1. What is the total weight of the ship? 2. What is the vertical center of gravity of the ship? 3. Will the ship be stable? 4. How heavy would the crew have to be for the ship to be unstable?
Hey Brian, I was tasked with finding out if our 24-inch platinum snow throw could throw snow at least 40 feet. One of our competitors is marketing that as a feature, and we want to be at least that good.
Huh, that doesn't sound too hard. What information do you think we'll need to solve this problem? We can use one of the projectile motion formulas to calculate the range of the snow. The range R is how far the snow will be thrown in a horizontal direction, which should be at least 40 feet. As you can see, the range R is shown as the horizontal distance that the projectile travels. Before we can calculate the range, we need a few things. Do you know what they are?
We know the snow is guided out of the snowblower from the chute. The chute must have an angle on it, which would be angle theta from the projectile diagram. I should find that angle.
That's right.
I looked at the snowblower and determined that the chute angle has an exit angle of 51 degrees.
The formula for the range R of the projectile is R equals u squared sine 2 theta divided by g, where u is the exit velocity in feet per second and theta is the exit angle in degrees. I hope you know what g is. We're working in imperial units.
I know I'm green, but not that green. Come on. The gravitational constant in empirical units is negative 32 feet per second squared.
Correct. We refer to it in the negative because gravity pulls on the snow in a negative direction. However, for our calculation, we'll use the absolute value of g. So how do we find the exit velocity of the chute?
The snowblower is a fan, which sets the velocity of the snow coming out of the chute. The owner's manual lists the fan speed at 68 feet per second.
Great. We'll use 68 for the value of u. It looks like you have everything you need to calculate the range. Let's see what we get for a distance.
Click on this video link or visit our website for more free videos and lesson plans.